over x minus a. All right, so that's the standard thing, right? You just have to remember that. And now we plug things in. So f of x is just the function itself, minus, set of parentheses, f of a is just plugging a into the function. I think this part's easier. For the first definition, I think the numerator, doing this is easier for the first definition because you're just plugging in x and then you're plugging in a, right? It's not as complicated as plugging in a plus h. So that I think is easier over this. All right. So now what? Distribute? Yeah. Let's distribute? Okay. Limit x goes to a, x cubed minus 3x plus 1 minus a cubed plus 3a minus 1 all over x minus a. Hey, we actually have some good stuff here, don't we? Do y'all see the ones go away? All right, the ones go away. So I have limit x goes to a. Then I have, what is that? If the ones are gone, what do y'all want me to do?
Rewrite it.
You want me to rearrange it again?
Yeah.
How?
X cubed minus a cubed.
X cubed minus a cubed.
And then minus 3x.
Minus 3x, and then minus, or plus 3a. Do y'all see where this is headed?
X minus a times x squared minus, is it
Yeah, there's a formula for this, right? This is a difference of cubes formula. And it's in your formula sheets. If you don't remember it, it's there. Most people know the x squared minus a squared, difference of squares, and I would expect you to know that. But difference of cubes, not as common for people to be okay with that. So yeah, I'll write it down over here. For us, it'll be this. X cubed minus a cubed will be x minus a times x squared plus x times a plus a squared. That's the formula for the difference of cubes. Check your formula sheets. It's there. So this is going to be kind of ugly, but let's do it. This is limit x approaches a. Okay, this becomes x minus a times x squared plus xa plus a squared. That's just this difference of cubes. That's all that is. Everything up there is this. Now over here, what should you pull out? Negative 3. Just negative 3, right? Negative 3, and that leaves you with x minus a, and then all of this over x minus a. And do you see that you have x minus a's everywhere now? And you can cancel it out. Okay, if I cancel it out, now let all my x's become a's. So this becomes a squared plus a times a, another a squared, plus another a squared, and I still have this minus 3, because this canceled, but I still have a 3 there. And that's just 3a squared, nope, 3a squared minus 3. There it is. Please do not lose sight of what's going on here. We have a cubic function, right? This is a cubic function from college algebra. It looks something like this. What that formula does is it allows us to pick any value we want for a. Like, give me a value. 2. Okay, good. If I plug 2 in, right, and go to the function, the slope of the tangent line there is whatever I get when I plug 2 into that formula. So what would happen if I plug 2 in here? 2 squared, 4. 4 times 3 is 12. Take away, so 9. The slope of 9 is pretty steep, right? So I can tell you that at 2, at an x value of 2, the slope of this tangent line is 9. So the instantaneous rate of change is 9 at that point. You want to go with a different point? Let's go with 1. You go to 1, plug 1 in there, and what do you get? 0. Hey, so that would mean that it's flat, right? This tangent line. And so on and so forth. So I just don't want you to lose sight of the fact, like what this represents, right? This is a generic formula that allows us to find the slope of the tangent line at any point A. All you have to do is provide the point, okay? All right, so the algebra, let's look at the second definition. How are we doing on time? Second definition, h goes to 0, right? F of a plus h minus f of a all over h. That's our generic definition, and now we start plugging things in for this particular function. When I say f of a plus h, I'm plugging a plus h into this, right? Everywhere I see an x. Oh man, okay. So a plus h cubed, right? Minus 3 times a plus h plus 1. So that's what happens when I plug a plus h into the function, right? Subtract from that whatever I get when I plug in a. So plug a in there, you just get a cubed minus 3a plus 1. The entire thing over h. And what I'm hoping for is that that h is going to cancel, right? So what's the good and the bad here? I mean, the good is we don't have to factor anything, but the bad is we have to do a plus h cubed. And this is why I was kind of showing you the Pascal's triangle, is that this is exactly off Pascal's triangle. We can do this quicker than normal. So if you go back and look at last class, I mean, I'll just tell you what it is. A plus h cubed should be a cubed plus 3a squared h plus 3ah squared plus h cubed. So the powers on a go down, right? A cubed, a squared, a gone. The powers on h come up. No h's, h squared, h cubed. So that's what happens with the a and the h in terms of powers. And then the numbers 1, 3, 3, 1 come from the third row, or sorry, 1, 2, 3, the fourth row. Technically the first row doesn't make a lot of sense, but we call that the 0th row, and then the first, second, third. So from the third row, third power, you get the numbers. So this becomes limit h goes to 0, a cubed plus 3a squared h plus 3ah squared minus 3a minus 3h plus 1 minus a cubed plus 3a minus 1. So I've done the expansion of this, right? That's the first 1, 2, 3, 4. Wait a minute, hold on, I'm missing something, aren't I? What am I missing? Missing my h cubed right there. Hold on. I just forgot to write it. A cubed plus 3a squared h plus 3ah squared plus h cubed. There we go. So everything here, right, all of that is just this piece right there. And then the rest of it is me distributing, right? That's just me distributing here, here, that's those two, plus 1, negative through, got all that, all over h. Do good things happen? Yes. Let's see. Doesn't matter where you start here. 1s are gone. What else? A cubes, 3a's. Did I miss anything? I don't think I missed anything there. Did I? Everything that's left has at least one h though, right? And that's what we wanted. So limit H goes to 0. Okay. What should I do here? Can I pull the H now?
Yeah.
Okay, H, and then that would leave me with 3a squared plus 3ah, because I pulled one of the h's, plus h squared minus 3 all over h. So all we did there is pulled an h out of this one, h out of this one, h out of this one, and an h out of that one. Now they're gone. And finally, last step, let h go to 0, right? Replace all your h's with zeros, and you'll be left with, let's see, that doesn't have an h, so 3a squared. That has an h, gone. That has an h, gone, minus 3. Same answer, yes? So far, the second definition is looking like a winner, isn't it? Is it all right if I hand your quizzes back from last time? Any objections to this going around? The grades are on them. And then there's also, I think, the first quiz on here too, so please just grab yours out of there. And then I will also pass around the sign-in sheet, please. Bless you. Again. After you go through that, there's the sign-in. You ready? Time for a harder function. So how about 3 over the square root of 9 minus x? I want us to find the slope of the tangent line at any arbitrary point A. So what definition do you want to use? I don't care. You have to pick. You want to try the new one? Okay, let's try the new one. So we're going to use a new definition. This is going to be the limit h goes to 0, f of a plus h minus f of a all over h, right? So that's our definition. And now let's just plug things in and then try and crank out the limit. Limit h goes to 0. All right, what happens when you plug a plus h into this function? Yeah, you're going to get n 9 minus a plus h right there, right? Ooh, okay, that's good. That's already going to be bad. 3 over square root of 9 minus, I'm going to do it in a different color just so you can see. I'm plugging in a plus h right there for x, right? I'm replacing that x with a plus h. Now, I subtract from that f of a. Now, this one's not as bad. You're just going to replace the x with a, right? So 3 over square root of 9 minus a. Right? All over h. While you're sitting there looking at that, crying, I want you to look at the second definition over here. I mean, sorry, the first definition, if we did it the other way. F of x would just be 3 over the square root of 9 minus x minus f of a, which would be 3 over square root 9 minus a, then all of this over x minus a. That's the first definition we learned. That's what it looks like. and this is the second definition. This is what it looks like. I mean, I don't know. Yes?
To get the common denominator up top, we can multiply it by 1 over the square root of 1 minus h.
Square root.
No, maybe.
Well, so you said common denominator, so you're thinking you want to put these together, right? I mean, that's what we've done every time we've had complex fractions, right? Fractions within fractions, we get common denominators. So I agree, that's where we're headed, okay? We have to get a common denominator here. Same over here though. I mean, we'd have to get a common denominator as well, so that right now it doesn't look like there's any advantage to one over the other. The question is, what's the common denominator? So algebra students, or calculus students, algebra students, they always seem to like make this more complicated than it has to be. Basically what you need is, you need this entire denominator on the top and bottom here, and you need this entire denominator on the top and bottom here. That's what you need. So I'm going to do it in a different color because I'm going to do root 9 minus a on top, root 9 minus a on the bottom, right? I'm going to multiply top and bottom by that on the left one. And on the right one, I'm going to do root 9 minus a plus h. I know it looks terrible, just do it though. I mean, you don't have any other choice, okay? Root 9 minus a plus h. Even though it looks bad, you have to do it, right? This is the algebra. All right, let's see if we can handle this. Limit h is going to 0. All right, when I do the left top right here, I'm multiplying these. I have to multiply this times 3, right? So that's just going to be 3 sitting in front of that root. 3 square roots of 9 minus a. Okay? Now, I'm going to wind up subtracting, right? Because these have the same denominators now, so I'm going to wind up putting them together. So I'm going to subtract from that whatever I get when I put this times this, right? Which again is just 3 times the square root of 9 minus a plus h. What is the denominator of that expression right there? That's all, everyone's got it? Thank you. What is the denominator of that? Because I've already put them together. So what goes on the bottom here? The two roots multiply together, right? So don't try and multiply them, just put them side by side. Root 9 minus a times root 9 minus a plus h in parentheses, like that. Right, that's what the common denominator is. Any questions there? No? All of this divided by h. And remember, we're trying to get this h to cancel, and right now it doesn't, I don't see an h free anywhere, do you? No. So what do you think is going to come next? Go ahead. Conjugate. Exactly. Let's do the conjugate. Because now we have roots, right? We have these roots up here. Maybe there's a way we can put these together in a way that the roots go away. Yeah, the conjugate, right? So, yeah, I mean, look, this sucks, right? But it is what it is, right? This is your life right now. Okay? So I'm going to multiply by the conjugate on top and bottom right here. The conjugate that I'm going to use is 3 square roots of 9 minus a plus 3 square roots of 9 minus parentheses a plus h. By the way, I could, if I want, factor the 3 out and not worry about it and just have it out here, but I'm going to just leave it. I'm just going to leave the 3 in there anyway. So I'm going to be multiplying this and that together. Right? But remember, I need this on the bottom as well. So I've got to put it down here. 3 root 9 minus a plus 3 root 9 minus a plus h. You know, when I say things like, you know, the algebra and this is your life. It's not meant to sound condescending. When I was in Cal 1, my professor just expected us to know this. Like, it wasn't like, he didn't even make me feel better that, you know what, this is a little bit tricky. It's just like, here it is, you know? So I'm only saying it because if it seems like, what, you know, kind of crappy, it's because it kind of is, all right? But you just have to grind through it, all right? All right. Wow, all right, let's multiply. So let's do this multiplication, here to here. What happens there? 9, right? So the 3 times 3 gives you 9. And then the root goes away, right? The root 9a times root 9a, when you do those together, the root goes away. So I'm going to have a 9 times, the root went away, so what was left? 9 minus a, but I need 9 minus a to be in parentheses. That 9 that you get from the 3 times 3, if you're having trouble seeing that, you're doing 3 times 3 times root 9a minus, or times root 9a, 9 minus a. That's what you're doing, right? You're multiplying all those together. These two together gives you 9, and these two together gives you 9 minus a, but you still have to multiply those two together. So that's where I am. What about the middle terms? They're gone, right? Okay, so I only really have to worry about the last terms, which is this times that. And notice I have a plus here and I have a minus here, right? So I'm going to have a minus, right? Minus. And then what? 9 again. And then parentheses, the roots go away and you get 9 minus the a plus h in parentheses. Okay, that's it. That's what the new numerator becomes. Now all of that is over this disaster of a denominator. Look at this thing, right? Look at that. Horrible looking. Don't try and clean it up, just write it down. Square root 9 minus a. Square root 9 minus a plus h. Times, now I have this thing I introduced, the conjugate, square root 9 minus a plus 3 square root of 9 minus parenthesis a plus h. Okay, need a longer division bar there. There. Right, that's that denominator. It's all this. I write it down right? All of this over h. So don't forget, we have that h down there. All right, if there's any mercy from the math gods, an h is going to cancel here. So let's start cleaning up the numerator. Let's distribute through. 81 minus 9a, right? Right here, look at the inside of this. Isn't this 9 minus a minus h? Isn't that what that really is in there? When you distribute that little minus through the a plus h? Minus a minus h. And now hit everything with a negative 9. Right? This negative 9, hit it through. And what happens? Minus 81 plus 9a plus 9h. All over. I wish I could like right-click copy this, but I'm going to have to write it by hand. Copy, paste. Okay, all of that times all of this. What a freaking mess, right? All this over h. Do good things happen? Yes. Yes. 81's gone, 9a's gone, and the only thing left is 9h, and it has just an h, right? And that h will cancel. We had to kind of beat it up with algebra a little bit, right? But we got it to go. Okay, so when the h's cancel, I don't want to have to rewrite the whole thing, okay? So that's why I'm just canceling them now. Let's talk about what happens now when all of your h's in that expression go to 0. You will get, yeah. What, do we have anything left up here on the very top? A 9. Don't forget that 9. We have a 9 on top. Okay, over, let's see. H is going to 0, right? H is going to 0. So does it have any impact on this? No. So I have a square root of 9 minus a still. Okay, and then now here, look. If this h goes to 0, isn't that just 9 minus a again under a root? So square root of 9 minus a again. Okay. And then this is 3 times the square root of 9 minus a plus 3 times the square root of, hey, same thing, right? That h goes away. So I'm going to write it this way. 3 square root of 9 minus a plus 3 square root of 9 minus a. Right? That's what we have. That is the answer. But we can clean it up a little bit. There's a little bit, I mean, we've done this much algebra, right? So there's more we can do. Look, this is a root times a root. The root goes away, right? So that's just 9 minus a. And then I have 3 of these plus another 3. So how many is that? 6. So times 6 of these root 9 minus a's. That is probably a decent enough version for us to put a box around it and be happy.
So if you'd gone with the first definition, would that have been any cleaner?
I don't think, well, I think the first definition, we would have done the same thing. We would have got a common denominator. We would have had to do a conjugate. Maybe it would have been a little bit nicer. Same methods, though. The same things would have to happen, though. Okay. So I'm curious. What's the slope of the tangent line here at 5? So if you graph that function, right, if you graph it and you go to the value 5, what's the slope of the tangent line at 5? So you have to plug 5 into that, don't you? So it's 9 over, let's see, 9 minus 5, that's 4 times 6 times 9 minus 5, 4, square root of 4 is 2, so 6 times 2, 24, so 9 over 48? 9 over 48. Positive number or negative number? Positive, so it should have a slight slope to it, right? Let's look, let's see, okay? Let's see. How about we do the original function, which was 3 over the square root of 9 minus x. All right, and I said to go where? To 5? I'm curious how quickly you could give me the equation of the tangent line. This is the slope of the tangent line at 5, right? Can you give me the equation? What would you need? You already have the slope, don't you?
Yeah.
You need a point. Do you have the point?
No.
But you know the x-coordinate, don't you, is 5?
Yeah.
How about the y-coordinate?
3/4.
Plug it in there, right? So if you plug 5 in here, you get 3 over 3 halves.
Yeah.
Now you have a point and you have a slope, don't you? So you can do y minus y1 equals m times x minus x1. So that's what I'm going to do. I'm just going to go here. Let me just plot the point 5, 3 halves. There's the point on the graph, okay? I don't see it. And the equation of the tangent line should be y minus 3 halves equals our slope, 9 over 48. x minus 5. There it is. We have found the equation. Now, really, I just wanted the slope, right? Well, really, I wanted the formula for the slope at any point. But using that, I can now find the slope at a particular point, and then even further, I can find the equation of the tangent line at any point. And do you see how easy it would be now if I just gave you a different value of x? Right? If I give you, how about at 8? What if we plug in 8? Right? If I plug in 8, what do I get there? 3. And then if I plug 8 into this, what would I get?
6.
9 over, let's see, 1 times 6, so 9/6. So the slope would be 3/2. Am I moving too fast? If I go to a second point, 8, 3, there's my second point right there. I know the equation of tangent line is y minus 3 equals the slope, which was 3/2, 1.5, x minus 8. There it is. I can do this all day long now, right? Because I've got this master formula. It took me, I had to work for it, right? But now I've got it. We understand? All right, how are we doing on time? We got time. Let's do another one, last one. How about, I'm going to use a different variable. F of t instead of f of x equals, look back in your notes. I didn't give you one like this last time, did I? I don't think I did. So look, t is like the x, okay? That's all it is. T is the x. So I want us to find f prime of a. I want the derivative of that function at a, which corresponds to a formula that gives us the slope of the tangent line or the instantaneous rate of change of the function at a, right? We have choices. Y'all want to do the second one again just to get one more on it, just so we have some practice? Yes? Okay, so I'm going to use the second definition. Limit h goes to 0. Okay, it's the definition is f of a plus h, right, minus f of a all over h. This is the limit